Hello everyone, I'll be explaining problem D of Codeforces around 840 valid Bitonic sequence. So what does the problem say? Basically, you are given five things. You are given a size of an array. You are given 2 points, two indexes in the array, one with indexes A and B, and you're also given what are the values of those elements. So maybe for example, you're given this sequence of 6 length, and you know okay that this element is 3 and this element is 5. So knowing this information, you need to find how many ways I can uh, uh, put values in the other blank indexes such that number one, it's a permutation, and number two, it's a Bitonic permutation, meaning that the permutation increases till a particular index and then it decreases. So uh, and it needs to at least increase once. So it cannot be like it cannot be in a completely descending order, and it cannot be in a completely ascending order. It needs to first go ascending till at least one index, maybe this index, and then it needs to decrease. Okay. And in the example, they've also given some example of Bitonic sequences. So how do we solve this? Okay, let me erase this. Okay, so for starters, we'll be assuming a few things, and then we will basically, once we get the answer for them, we can modify it to get the answer for other cases. So the first assumption that we are making is x is less than equal to x, and x is less than y. X is basically the element at index A and y is the element at index B. The second assumption we are making is y is not equal to n. So if we are able to find the answer for this case, if we had something like x greater than y, what we could have done is we could have reversed the array, uh, replaced A with n minus b minus 1 and replace b with n minus a minus 1, and we can swap an x and y, and then we can just uh, reuse the answer that we had in this case. And if y is equal to n, then also it's a simple way. Once we get the solution, we'll be able to figure that out. So let's proceed. Now we are given something like this. Okay, we are given an index. These points represent the elements, and a index and b index, we have some value x and y. And like we said, x is less than y. So what can be the pattern of a Bitonic sequence here? Um, can it? Let's take some more elements here. So can it first decrease, like can it increase before A? Meaning that um, can it increase to some point before A and then can it start decreasing? Uh, well, that's not possible because X is less than Y. So like this sequence can never be decreasing because these two elements are gonna uh, have a conflict. So the sequence must increase till X at least, and afterwards it may decrease. Okay. In that case also we have two possibilities. So the first possibility is that we increase at least till some point after B. So we can have a sequence which increases maybe till here and then it decreases. Okay. Also, we cannot say that it increases till B because this is the peak and this has to be equal to n, and B is not equal to n. So it has to increase till some point after B and then it has to decrease. So what are the number of ways that this kind of arrangement can happen? So to do that, what we can do is we can um, iterate. So we can iterate over uh, the ranges from b plus 1 to n minus 1, and we can assume that okay, uh, let's say that the peak happens at some point that we are iterating over. So maybe we are here at b plus 2, so we have k equals to b plus 2, and we say okay, the peak goes all the way till here, so this is n, and then it will decrease. So we now know three things. We know till where n is gonna occur, what the values of a and b. So using this, we will now try to use combinatorics to find an answer. So I'll just simplify what we have. What we basically know that now is that okay, at some point A, we have value X. Afterwards, at some point B, we have value Y. And then at some point K is between um, B plus 1 and N minus 1. So like Y cannot be N, it cannot be N because in that case the sequence will be like completely ascending and we don't want that. So at some point till K, we have the value N, and afterwards the sequence have to decrease, okay? So first thing is that the sequence increases till this point, okay? So what all values can be put here, what all values can be put here, and what all values can be put here, that is what we need to find, okay? So of course here we will have to put values which are less than x, because if they are greater than x, any values greater than x, then this part will not be ascending. So um, we need to choose a minus 1 values because this is at index a. So suppose this is 1, 2, 3, 4, and 5 index. So we need to choose 4 values, a minus 1 values, such that they are less than x. So from x minus 1 range, we need to choose a minus 1 values. This is the first part. What about the middle region? So for the middle region, we need to choose b minus a values, b minus a minus 1 values. So if this is 5, this is 6, this is 7, this is 8, and this is 9. So we need to choose 3 values, which is 9 minus 5 minus 1. And what is the range of that? We need to choose values between x and y. How many values are there between x and y? Not including x and not included y. That is y minus x minus 1. That's the second part. And the third part is we need to now choose uh, some values. How many values? K minus uh, b. Let me confirm. Maybe this is 9, this is 10, this is 11, this is 12. So we need to choose, yeah, we need to choose k minus b minus 1 values. From what range? Basically between y and n. Y is, we already know the value, n is already taken. So how many remaining are left? We are left with like n minus y minus 1. So this is the third term. And once you have chosen the values, all the remaining values will go here in a descending order. So you can just, you don't have to do anything for this part, and you can just multiply them. And you will do this for all the k's which will go from b plus 1 all the way till n minus 1. Now, okay, so now let us look at the code and let us see how this is done. Um, so I have called a function p1, and P1 has two loops. One is for a special case of y equals to n, which I'll talk about now, and the second is okay, otherwise what we need to do. So basically, I have done here till k less than equal to n. So you can also do till k less than n, and you don't have to do this. This is like a if this is like a special condition where you have to subtract, but you don't really need to worry about it. So v1 is equals to, like I said, choose values like here, x minus 1, c a minus 1. So this is v1. You calculate v2, and v2 is similar, y minus x minus 1 and b minus a minus 1, and v3 equals to, you are choosing n minus y minus 1 and k minus b minus 1. And then you can add them and then you can return that. This if condition was had to put because I was iterating till k equals to n. So I'll just briefly explain why I had to do this. Basically, if there was a special case that the array looked something like uh, if the array looks something like you had third index may you had 3 only, and fifth index may you have 5 only, and you were saying okay, this value k equals to n, this value has to be equal to n. So there's only one solution to this, like it will be a completely ascending array, and we don't want that. So that's why I was subtracting one for this uh, array in ascending order that was being counted. Okay, but you can just do till k less than n and you'll be fine. So this is the first part, and I will just now talk about what we do if y equals to n. So if y is equal to n, then it's also very simple. Uh, maybe at this point y equals to n. So you now already know that the array will be going all the way till here, and then it will be decreasing. So the only thing you need to do is you don't need to iterate over n like k, because uh, like this is n, and um, k, we iterated over k to find out what were the possible values where n could be present, but now we know n is present here only. And if you had x somewhere here, so you can now just simply do the combinatrix here. It would be like um, x minus 1 c a minus 1, and here it will be like the same thing, y minus x minus 1 c b minus a minus 1, and everything else will be put here in a descending order. So like that was the uh, only thing that you had to worry about. So I have done the same thing here. So I have like chosen two things, but like less than a and between a and b, and I added that to the base. And this is like I talked about the special case of the array being an ascending order. So what would have happened if maybe y was this like y like b was n, and y was n. So and like a was also the same as the index it was present at. So if a was 3 and x was 3, then uh, you will have you can have one ascending um, permutation being counted, and you need to subtract that. So I was just doing that here, and that's how you solve the first case. The second case is also uh, on the similar grounds. You're gonna have to solve it. So I'll also briefly go over it. So this is the first thing that you need to add to your answer. The other thing is, what will you do if the array first increases till some particular point, and it then decreases uh, all the way till n, and that particular increment point is between a and b. Now, of course, here y cannot be equal to n, because uh, if y was equal to n, then we have already considered this case where the array goes till ascending till here, and then it decreases, right? So that was already counted in P1 function. So like here, it's necessary that y is not equal to n. So what you can now simply do is you can iterate over this range, like between a and b. So suppose you pick up this point and you say, okay, now this guy is n. So this point k is n. So the array increases till here, and then it decreases. So now you have these three sort of ranges that you need to worry about: this range, and this range, and everything else can go here in a descending order. So how do you calculate this? Well, let me write it down here. So you have some x here, you have some y here, and you have an n here. Okay. Now this part is similar, so you don't need to do anything different. You just need to find uh, a minus 1 values which are less than x. Okay. So you will basically be using some values, some a minus 1 values you'll be picking from this range. Okay. Now let us solve this part first. Okay. Let us label this 1, let us label this 2. So let us solve 3 first. So what we need in 3, we basically need b minus k minus 1 values which are lying between y and n. So n minus y minus 1. Like for an example, suppose k was 4 and b was 8. So we need 8 minus 4 minus 1, which is 3 values for the index 5, 6, and 7. And these values must be greater than equal to y, and they must be less than n. So basically they should be in the range of y plus 1 and n minus 1. And this is equal to like n minus y, uh, n minus y minus 1 minus 1 plus 1. Yeah, so it is going to be n minus y minus 1 only. So the answer to this range is going to be n minus y minus 1. Um, you have n minus 1 minus y minus 1 values, and from that you have to choose b minus k minus 1 values. And so if you look here, so basically what we have done is from this range we have took some values. Now how many values have we took? We have took b minus k minus 1 values. Now finally, to solve for this range, we basically need some values between, and this is a little tricky to understand. So we basically need to have some values between x and n. Those values, and we have to take how many values? We have to take k minus a minus 1 values. Okay. But the thing to understand here is that you need to completely exhaust this range as well. Because try to understand, if you like, you have to pick k minus a minus 1 values from this range. If you only picked values like from here, and there were some indexes which are not chosen, which were left remaining. So now these indexes have to go in this range, in the last range, but these values will be greater than y. So you won't have sort of a descending arc. Like, you will have, if a value is greater than y, then you will have like again increasing and then maybe decreasing. So you need to completely exhaust this range. So first, you need to check, okay, how many values were remaining here. Suppose uh, like the total number of values in this range that you were able to pick were n minus y minus 1. From that, you have already picked b minus k minus 1 for for this. So these are the remaining. So these you have to pick. No choice you have. Now, if you have picked these, how many are you left with? You are How many are you left with to choose? So you're left with to choose like k minus a minus 1 minus this. Because previously you could have chosen these much values, but you have to like, you have to completely exhaust this range. So you have no choice but to take up all the remaining values in this range for your for the second region. So these are how many you are left with to pick, and you have to pick them from the range of y minus x minus 1. So this is going to be the third thing that you are going to be adding. So, and then you will just multiply them and you will add them. So I will also show you the code for that. So we iterate for k equals to a plus 1 and less than b. So which is the point where n will lie. You have three values, v1, v2, v3. So v3 is simple, like values which are less than x, and you have to choose a minus 1 values. Similarly, v1 was the values which were between n and y. So you have n minus y minus 1 value, and you have to choose b minus k minus 1 from them. And like, and then you have this last range. So this last range is, you have y minus x minus 1, and from that you have to choose k minus a minus 1 minus how much you choose, how much you have to choose from the range between y and n to completely exhaust it. And then you just add it and then you return it. So this is sort of this is the trickiest part, I would say. Apart from that, the implementation, like once you written this, and it took me a lot of debugging to write it, but uh, just then you can just find p1 and p2 and just you can print their sum. And we have now already handled in the beginning. I told you, like, we are taking um, two assumptions. One second. Yeah. So we are taking two assumptions. Y is not equal to and x is less than y. So for y equals to n case, I already told you what we have to do. If x is greater than y, so if x is greater than y, now suppose um, let's say you had x here and you had y here, right? So you basically, like we had, you had uh, now here also you have two choices. So you can have a sequence which increases here and then it decreases, or you can have a sequence which increases till this point and then it decreases somewhere in between them. So you can also think of it in a reverse direction. So you can think of maybe the sequence um, increases like till here. Uh, like, what I'm trying to say is that you can just reverse the array. So what will happen if you reverse the array? You will have something like y here and x here. But now you need to ensure that, okay, this, like, if there were no, if there were like 10 values here, so now this has to be at the 11th index here only. And similarly, if there were like 15 value here, so the new position of uh, uh, the new position of the index where x is present has to be at like n minus 15 only. And you will just change the naming. So because we assume that x was less than y, so you will now call this x new maybe, and you will call this y new, and you will now call this index a, and now you will call this index b. So you're just reversing the array, and you will find the answer the same way. So this is what I've done. If x is greater than y, then swap x and y, and also just rename a and b. You can like try to dry run this part of the code, and you will understand what I'm trying to say. So that is the solution to this problem. I know it's like very huge, and you might not have understood it completely at one go. So maybe try to go through the video once again, and if you have any issues, you can post them in the comment. So thank you for watching. Bye bye.